Let's take a look at the substitution rule, but this time in a definite integral. We've got an integral from 0 to 5. On the top, we have 9x cubed, and then on the bottom, we have 8x to the fourth plus 1. The first thing that we need to figure out is what is it that we are going to denote by u. Okay, so usually what you do is you look for some sort of parentheses, and whatever's in parentheses, that's what u is. So maybe it's an argument of a sine function, or maybe log, or whatever. But here it doesn't look like there's anything in parentheses. But think of the bottom as whatever is on the bottom raised to the power 1, right? Then we just introduced the parentheses, and so then your u is 8x to the fourth plus 1. Okay? And of course, power 1 we don't have to write, so I'm just going to get rid of it, but that would be like the reason why I do that. And I'm thinking it's going to transform to something like 1 over u, which I know how to integrate, right? Because 1 over u is natural log. Okay, now let's find du. Okay, so du would be, what is the derivative of 8x to the fourth power? So we bring the power down, that's going to become 32, and then we reduce the power by 1, 4 minus 1 is 3. I see a lot of students leaving this just like that, and not remembering that du is not just the derivative, it's the differential. What's the difference? Well, you have to take the derivative and multiply it by change in x, okay? Because you're saying change in u is whatever times change in x, and this change in x is dx, okay? Now, why is this so important? Because you need to transform your integral into something that has x to something that has u only. Okay, that's your goal. And you can't just assume that dx and du are the same, because they're not. Because from here, you can go ahead and solve this for dx by dividing everything by 32x cubed, right? So I'm dividing everything, and it's going to cancel here. And then my dx is going to be du divided by 32x cubed. Okay, so now let's go and see what happens. I am going to leave the top intact for now, so that's 9x cubed, and then whatever was on the bottom, that's what I denoted by u, and then instead of dx, I'm going to substitute what I just found what it is, which is du divided by 32x cubed. And the way these problems are usually structured is that you will be able to cancel the x so that the new problem will have only u. Now, here is something where I differ with a lot of calculus teachers. What they do at this point is they transform the limits, because remember, these limits are the x limits. So these are really x equals 0, x equals 5. And what they do at this point is they change the limits. So these limits, the 0 and 5, are not going to be 0 and 5 anymore. What they do is they plug in x equals 0, they would get u equals 1, so that bottom limit would have been 1. And then they plug 5, well, whatever is going to be 8 times 5 to the fourth plus 1. I don't know what it is. I do not do that. So just for me to remember that I did not change the limits, I am going to put x equals 0, x equals 5. So yes, I transformed everything in terms of u for now, but I'm keeping the same old limits. Okay? Let's go ahead and integrate. Now, first of all, 9 over 32. Can I cancel something there? I don't know. I'm just going to leave it as 9 over 32. I'm not sure that 32, I don't think, is divisible by 3. I don't think we could do anything with that. But our integral really becomes 1 over u du. And again, the limits for now, I'm just going to say x equals 0, x equals 5. Okay. The integral of 1 over u is natural log of absolute value of u. However, in this case, I don't think anything is going to be negative, so I don't really need to put absolute value. So this is just going to be natural log of u. And because we made a note, and this is very important, that this is x equals 0, x equals 5, you are not ready to substitute in here, because here you see u. That's where I differ. I don't change the limits, but I do go back to all the way back to the original variable, just like I do for a regular indefinite integral with no limits. I always have to go back to the original variable, which was 8x to the fourth plus 1. And now I can actually substitute my old limits. I prefer that to changing the limits because sometimes students just forget to change them and then they start plugging in 50 into u. But you need to realize that that were your x limits, not your u limits. And I'd like to always do everything like it was an indefinite integral, go all the way back to x and then plug in the old limits. Okay, so I'm going to have 9 over 32 natural log of 8 times 5 to the fourth, which whatever that is, plus 1, minus, let's substitute the bottom. So this is going to be natural log of 0 plus 1, that's just going to be 1. Now, one thing that you do have to simplify, so this is very important, is you do not want to leave this like that, because natural log of 1 is actually 0. My answer is just going to be this right here. Okay, so let me quickly put everything in here that I already did, just to make sure, just to check my work. And then over here, I got that 9 divided by 32, and then I had 1 over u, right? Okay, so let me just put the space there. Then I integrated that part. Not sure I submitted it. Okay. And I kept the constant, so I got natural log of u. Then I went back to x, so I got 8x to the fourth plus 1. And finally, okay, it wants me to separately compute it. So this is going to be 9 over 32, natural log of, okay, what is 8 times 5 to the fourth plus 1? Let's open up Desmos here. So this would be 8 times 5 to the fourth plus 1. Okay, that would be 5001. So that's going to be here. This guy is going to be 0. And then this we'll just copy paste over here and see. All right.